Sounds good.
All right, thanks again. Have a great event. Thanks again all for joining us. Have fun. Ryan will be leading the way. Ryan's a great guy, and he'll be sharing stories from where he's been um, throughout the country and throughout the world. So if you haven't already, let us know where you're dialing in from. We'd like to welcome you properly.
All right. Thank you, AJ. Appreciate it. And thanks everybody for joining this morning, this afternoon, or this evening, or tonight. Boston, yes. So I currently reside in Florida, but I'm actually in the northern part of the country, in Ohio right now, escaping the Florida heat, visiting some family. So I apologize. Normally when we do these webinars, I'm in my studio at my house, and the audio quality and the video would be a little bit better. But have to work around schedules and don't want to stop the show. Yes, Bama is usually very hot and muggy. I was in Denver, Colorado last weekend, and it was hot in the 90s, but it was dry hot. And I was like, oh, this is not hot. I walk outside and I don't immediately have wet clothes, right? So, all righty. So welcome all. Thank you. This is part 4 of office hours for KubeAcademy, and specifically office hours for one of our sections. We have Learning Paths, which is a collection of courses. Courses are independent, but if we string some of the courses together, then it turns into this sort of guided approach to learn something. In this scenario, a decent chunk of information about Kubernetes and the core concepts necessary. We've already done part 1, 2, and 3, and we're on part 4 now about additional application features. So if you recall, we learned about containers, and we containerized an application in lab. We had this whole Go web app, 2-tier database of MySQL backend and a Golang web server on the front end. So we got it in there and got it working. Then we explored a little bit with Kubernetes to see what are the features of it. We said, okay, the app's in there, but now let's put a new version out. We explored canary deployments, blue-green deployments, rolling deployments, etc. And then in the cluster concepts, we explored the networking side of things and DNS namespacing, and then how we put stuff into different namespaces, the use of putting things into different environments, and so on and so forth. And now we're on something that we called additional application features. So that's a little history behind that. Once again, my name is Ryan Schneider. I'm the lead education engineer here at VMware and on KubeAcademy. And we use so I create the lectures and the lab materials, do some of the recordings along with my colleagues. And then if anybody's going to be at VMware Explore, I will be talking there in San Francisco at the end of the month as well. Question, missed the previous sessions? So if you haven't seen the previous sessions, they are on YouTube. I'll try to grab the link and put it in the chat. We have them up there. If you go to the VMware Tanzu YouTube channel, we have them posted. Let's take a look. Yeah, I don't know if we have a playlist for them yet, but for sure we'll look to get one. Almost there for you. Yeah, there's one there. And oops. All right. So here, part 2 that I'll put in. Thank you. Yeah. Thank you all for this. But they're up there, and this one, 3 should be soon. I don't know why it's not, and then this one will be as well. So you'll be able to go back, especially if you have an obligation you need to bounce early. All right, so let's get rolling on the part 4. And the whole idea here is to ask questions. Ideally, you might have had time to go through the lectures and also do the labs yourself. But in order to help get the ball rolling with folks, usually what I do is I go over sort of the high level of this course, and then I'll go and start doing the lab. And I'll just start talking to them, doing the lab, explaining why we're doing this stuff. And if you have questions as we go through that, please just belt them out there in the chat. So why did we come up with this name, additional application features, especially when one of the things is called statefulness or storage? Well, there's a lot to Kubernetes, a lot. And so if you break things down, incrementally reveal things, we have to admit that some applications don't need statefulness or don't need persistent storage, right? Web servers tend to be the stereotypical example of this, right? They're storageless. They're contacting the persistence layer behind them, which is your traditional database, a REST API, whatever it may be. And so that's also how a lot of people pick what they're going to put into Kubernetes first, right? If you're starting out or you're migrating applications from somewhere else into Kubernetes, they pick the web servers first, or the non-stateful applications. So that's why it's an additional feature. Not all of them require it. And then also dynamic application configuration, meaning that on the fly, I can inject in runtime configuration changes, right? So things like in prod, I use this URL for my third-party service. And in QA, I use this URL for my third-party service, and so on and so forth. One container and one image, and then I inject in the configuration at runtime from the environment as necessary. Okay. If you're just joining us late, this is part 4 of Kubernetes office hours. You can go to kube.academy, go to the learning path, and we are going over these parts right here. If you have questions on this material, please let me know. I'm going to start by going through the persistence lab, the stateful application lab, and just talk about it as I go, and it might spark some questions from some folks. So this first thing is that, this course is a connected thing, right? And we tried to carry through a theme through it of taking a 2-tier application and slowly enhancing it and building it up. And so what we have here is we are bootstrapping our lab up to the point as if you and I had went and did in one persistent lab environment that was long running, did the first 7 labs that carry over from parts 1 through 3 that we did. And so it's making the containers, it's creating the containers, it's making the YAML files, and then it's going to put it into Kubernetes. So you'll see if we do kubectl get pods right now, we're going to have nothing in there. It hasn't gotten that far yet. And our goal for this lab is we are going to take that 2-tier application, which is made up of web front end and the MySQL backend, and we're going to add persistence to the MySQL backend. When we started it, just, like most things, we try to avoid, many variables, right? Let's not turn everything on right at the beginning. We try to slowly look at things when we're trying to debug and put things in. So we put in and tried to make the application work in Kubernetes without persistence. And it did. And but now we need to add the persistence so that when the database restarts and so on and so forth, it'll be there. So it looks like our script has got to the point to where it's created some resources. So we should start to see some stuff in here. And yes, we do. That's great. Okay. And if you recall, if you put a -w at the end of a kubectl get command, what you'll see is it'll just watch it like tailing. So as things change, we're going to see that. Okay, so we're going to have to wait for things to hopefully work. I'm in demo world, right? So you never know what's going to happen. But I believe this is as expected, okay? And the reason why I say that, if we just let that thing roll, we have our pods, the web front end is crashing. Now, this is actually a fun thing to talk about here, because I do get asked this question sometimes as well. So this thing's eventually going to come around. There's a lot of turmoil happening in the system right now. Okay. And that's because this was a scripted way that threw the stuff in. Basically, we just threw both deployments and both services at Kubernetes and said, make it happen. And so what's happened is the web server, which is lighter weight, came up right away. And it tried to talk to the database, but it beat the database. The database hadn't started up yet, right? And so in this particular scenario, the web server was programmed to just crash and fail fast, as opposed to retry or other things. But because we're in Kubernetes, by default, it's going to continually retry. So it's going to, after the back off timeout period, it's going to restart the container. And that's what we're seeing happening here. And eventually, we will get to that desired state. So what happened was, it wasn't until the database booted up all the way, and then the health checks for the database had to succeed. Notice up here, we were at 0 of 1. So the database was running, that pod was running, but the health check that's examining the database to make sure the schema is there, that we get data back, etc., it had to succeed. And remember also, stereotypically, health checks, you need n number, usually 3, of consecutive successful health checks before you turn it quote unquote green, right? And so all of this took time, and then eventually on the 4th restart, we had what we wanted. And so, if we would have done this in a more traditional environment outside of Kubernetes, we would have had scripts or humans. Okay, let's start the database up. All right, let me know when it's up and looks good, right? And then, okay, after that's all done, somebody says, okay, everything looks good, you can now start the web server. Then the other person may, okay, look, go start the web servers, and then they come up and it's all graceful. So that's the rationale about why we see this. And it's actually normal in Kubernetes a lot of the time. If you want to avoid it, you can do so by instead of just dumping the directory of your YAML files at the system, you can bake in knowledge to know this, and then put those rules in accordingly. Question: how can we check the content of log file to see why crash is happening? Great. Yes, so in containers, when images are made, we typically set them as that we write the log messages to standard out. Standard out is then redirected by Kubernetes to log files in the file system. And therefore, we can then view them by using the kubectl log command. I'm going to go ahead and stop this. Okay, kubectl log. And we can look at the Go. Let's go look at the Go web app. If we look at the database one, for example, it puts the most recent to us here. And so this was a database starting up, invoking the InnoDB engine, and then eventually we get to where the port has opened and we have successfully started this version of MySQL. So you would do the same thing on the others. One thing to note is that depending upon your policy setup, as these pods IDs change, you might be looking at a pod that no longer exists. If you do have logging platforms set up, they would have been ingested into your logging platform as well. But kubectl logs is the easy way if you have that access. Okay, so we got this good. The Go web app database is currently a deployment with no persistence mounted to it. The author of the MySQL image basically said, I'm going to write data to this spot, and I'm going to allow the image to be started up even if you don't mount in your own persistent storage over top of it. Okay, so we're going to change that out for a stateful set. Does anybody remember what the characteristics are of a stateful set that are different from a deployment? And while you do this, I'm going to get down our template file here and put it into our environment. Well, there's three differences. A stateful set, first off, gives you a one-to-one relationship. It adds another rubber stamp where we're going to, for however many replicas are defined in the stateful set, it's going to make pairs. It has two rubber stamps. It has a rubber stamp to create pods, a template for that, and it has a template to create PVCs, persistent volume claims, and it marries them up together. So pod PVC, hook them together, put it over there. Pod PVC, hook it together, put it over there. Right? And it does that for however many replicas are defined, hence giving us unique storage for each pod in the system. So if our PVC defined 10 gig and I had the replica on the stateful set to 5, then at the end of the day, once it's in the system, I would see 5 pods, 5 PVCs, and a total of 50 gigabytes of storage allocated, 5 10s, each 10 to 1 to a pod. Okay. So the second thing it gives us is consistent pod names. So up here, you'll notice our pod name was the deployment name, go web app dash mysql dash the hash of the replica set dash the hash of the pod itself. When we switch this out, we will get consistent names that will remain the same as the pod comes and goes. This is important for pieces like Cassandra, MongoDB, Elasticsearch, etc. These systems, they don't really like it when the members of their cluster come and go. And then the third thing that we get with this is we get an ordinal. And so things come up and down in a organized order. So if I had 5 of them set, we go 0, 1, 2, 3, 4. And when I scaled it down, it tears it down 4, 3, 2, 1, 0. A lot of these same kind of systems I mentioned before don't like it if we just sort of start everything up all at once. Okay. Any questions pop up? Mind zooming in my screen? No, sure, I won't zoom in the screen, but I'll make the browser window smaller, which should help a little bit. We'll get a little bit more wrapping on the terminal, but I think it should be okay. You see my browser window, the Chrome window, correct? Hopefully that helps. Okay, wonderful. So let's go ahead and look at this. All right. So we have the to-dos. The first one, the easy one, is we're going to make this, instead of being a deployment, we're going to be a stateful set. Okay. Service name, we're going to set this to the same as the name of the actual Kubernetes service object, which also happens to be exactly the same. This used to be a requirement in a stateful set. There was an assumption that you always had a service fronting the stateful set. I believe this year or at the end of last year, there were some changes done where this is no longer required. I don't know if it's made it into the most recent version of Kubernetes yet or not. I'll have to check that. And they do allow headless stateful sets, essentially. The rest of this looks very, very, very similar to what we have already done in the deployment. until we come down to the volume claim template. This is that extra rubber stamp I'm talking about, right? So we're going to mount in storage. Volume mounts is the generic way to specify where we want a volume to show up in a container. Okay. We've already templated out or already filled out most of this for you. And then we're going to make the storage be 5GI, 5 gig. So what we've done is basically I could manually go make a pod and then manually go make a PVC and hook the two together. This does it all at once for us. All right. So let's go down to our instructions. We are going to also, every lab environment tends to have a little bit of peculiarities to it. In this one, we dynamically start up a registry for every session being done. And so what we're going to do is we're going to actually replace that registry name and credentials are in a environment variable, and we are going to modify that same YAML file I just looked at. If we go back up to where the image line is, notice that this registry name, which is dynamic, was basically substituted in. Okay. And now we are going to start it up to apply it. Oops. There we go. All right, in it goes. So, all right, well, we have a PVC now. I should have run that command before I did that, right? But you can see by the age of it, which is 4 seconds. And I apologize, I do need to, I don't want wrapping to happen, so I'll try to, hopefully won't make it too big for you. What we see by that is its age is 4 seconds. So it just was created. And this was created, I didn't make a PVC object myself, right? I gave Kubernetes one object, stateful set. This was automatically created for me. If I go back and look at the pods, notice my pod name up here when I ran this command before, I had the hash in the ID, and now I have MySQL-0. The replica size is set to 1 on this, so hence we start out with 0 only. All right, cool, it's running. Let's describe this thing. All right, so notice now we have a MySQL PV line here. So the PVC has found a PV. It's been mounted in, and notice the mounts here. Before we only had the standard service account mounted in, and now we have the varlib MySQL that's mounted in. Cool. All right, so test your application. So that Go web app, we're going to make sure that this thing actually works, right? So let's make sure it works. Let's go ahead and get the URL for this and load it. All right, I'm going to, I had done this before starting out, so I'm going to go ahead and do it again, see if I have it. Yes, I think I need to. All right, let's go ahead and register. Let's do KubeAcademy, kube@example.com. Foo. Great. Okay, let's log in with Kube. Kube@example.com. Foo. Okay, let's make a note. Make a note called hello webinar world. Okay. All right, we're in. Cool. So the one last thing part here, and then I'll get to some questions here, is we are going to also, just to double check, so we have tests, we're going to drop a file into, so we exec into the container and we're running a command. We're going to drop a file into the area where we mounted storage, just to double check. Right, so that's the file we just dropped in. And if we actually list that's inside the container, notice we see the other MySQL file. So we should see all this maintained. Question, can the storage class also be specified in the stateful set? Yes, it can. You can say what storage class. Basically, the entire schema for a PVC can go inside of that template. So if we go back to here on the left, this YAML file, this volume claim templates, everything under line 44 there, anything inside there, that's the exact same YAML that you would write if you were writing a PVC. Good question. Okay. So we got it. So let's break stuff, right? So what we're going to do, we're going to set our two terminals up so we can easily see this. One of the first things we're going to do is we're going to start and we're going to look at that, leave that going there. And we're basically watching, right? We're going to watch the stateful set. There's one of them, one's ready, etc. And then we're going to go and we're going to look at our pod. It's there. All right. They're about the same age. Well, we're going to go ahead and delete the thing. And Kubernetes is, of course, going to try to repopulate it, right? All right. So notice what we'll see here are in the down below, as we're watching it, notice that the pod has been deleted. So if I do kubectl get pods, look at that. Oops, I deleted it twice. I'm sorry. Oops. Yeah, be okay. Just gotta wait a little bit longer. All right. Let's go look at it again. So this is 2 seconds old, but our stateful set, our PVC is still 4 minutes and 44 seconds old. Sorry, our stateful set is still the older one. It went down to 0 of 1 ready, right? Once that pod up there starts to become running and ready, then the stateful set itself will return. We'll get 1 out of 1. And then if we describe this thing, notice now we have, see the mounts line here? We have we have 2 mounts. We have the varlib MySQL in there as well, and it references this PVC claim here. Okay, let's try it again. Hey, we're running here, and here in a little bit, we should see our STS stateful set go to 1 out of 1 as well. Question, in which scenario would it not recover or self-heal? Well, in the scenario where there is a problem external to Kubernetes. So for example, let's say that there were no persistent volumes available. So the storage array that gives out the persistent volumes, maybe it was not available. It had a bug, like network cable unplugged from it, whatever it may be. Kubernetes itself will continue to retry, but none of the retries will succeed until that external factor has been completed. Same with, or fixed. Same with like that image pull back off that you see a lot of times. Kubernetes will continually try to fetch the container and run it, but if it goes out to the registry and the registry says, hey, I don't have the image that you're looking for. Well, one of two, Kubernetes can't self-heal in that point. The act of healing now has to come from either A, the incorrect image line was put in the YAML file, or B, there was a timing issue or a mistake and the image is missing from the registry, or the permissions are wrong on the image in the registry. That would be another scenario where an external factor change is needed, human intervention, whatever it may be, for that to happen. Could also be a node issue. Yes, there are some more dynamics if you were sort of influencing things, right? And using if you were using affinities to pin pods to specific nodes and you didn't have enough of them available, that would be another scenario. And that's another thing where the operator admin, yourself or your colleagues would have to come along and add more nodes of that particular type back into the pool So there are ones there to satisfy the scheduler's request. Awesome, folks. I like the questions and the alternative scenario examples. Use cases always help. All right. So we're up and running with the MySQL 0 named pod. Let's go look at it. We already looked at it. So now let's go. We're going to first, I'm going to skip down to step 3. We're going to exec into this thing. And when we do so, notice the persistence, which was made 6 minutes ago, that file that we touched is still there, right? So that's good. It's great because we deleted the pod, but the pod came back up with the same name and it attached to the same PVC, which was backed by the same persistent volume. Wonderful. And then we can also check our notepad thing here. There's, I do apologize, there is some caching that sometimes go on. So if I log out, let's log in. Let's see, kube@example.com, foo. There's our hello webinar world still there. So we are good. All right. All right, cool. Let me pause for some questions here before I go and launch the next lab and we talk about it. I don't want to throw it away quite yet. So I know probably for some of you, this might have been some stuff that you've done before or that you knew about, but I also hope that it also might have been some things that you maybe hadn't thought of or hadn't thought about how it worked or tested it as well. And this is also just a reminder, Kubernetes takes a pretty strict approach that they do a separation, right? If you notice, we didn't say anything about where the storage was coming from. We just said in our STS YAML file, right? We just said up here that we'd like some storage of an access mode rewrite once and 5 gig. Kubernetes went and said, I'm going to try to find you 5 gig of storage. And so in this particular scenario, right, it went and it dynamically allocated a local persistent storage for that. It could go, if you're playing in a cloud environment like Azure or AWS, it might have dynamically made some block storage and then attached it. And they specifically try to do that and make that difference between the two. Because the utopian world is that you don't care. If you did care what kind of storage, you would put that storage class on there. And if you actually watch the lecture that's on KubeAcademy, the video of this, I go into a lot more detail about that. About the ways it can be done and stuff, but that's the sort of the idea behind it. Yeah, that was their goal, right? Like, let's face it, this kind of stuff happens in IT data centers and organizations all the time. That PVC, which says what kind of storage you want, how much, the kind, etc. Well, that's either put into a ticket in a ticket system. It's put into a Word doc that's done during discovery when you're asking for infrastructure. It's put into a Slack message, an email, or maybe you're walking over into the other room to the sysadmin room and the developer is asking the sysadmin, hey, can you go make me some storages and attach it to these 3 VMs or something? So like the same kind of stuff is happening, but we didn't have a standard way to represent it. And in Kubernetes, the PVC, PV, and pod deployment stateful set, that whole ecosystem of schema for the YAML files is attempting to standardize how we document and define that relationship. So it's clever when it works. And then, of course, there's the edge cases, right? All righty. All right, I'm going to go ahead and start up the next one. Let me go, while that's starting, I'm going to go back to here. The dynamic application configuration. So this is the one where what we do is we are dynamically supplying configuration to the application. Right. So meaning this is the same as like injecting in properties files, setting environment variables, etc. Okay, just waiting for this to start up over here. Just give me a moment. If you have other questions in the meantime, just let me know. All right. All right. Next lab here. Once again, we're going to do the same situation. I should have done that earlier. I apologize. Okay. So clever when it works. Yeah. All right. So what we're going to do here, the general theme of this, is we have the web application and the database, but there's some hard-coded stuff inside of it. What happened is, and this is sort of, once again, we intentionally did this. We sort of did some not great best practices to start with intentionally in this course so that we can fix them as we go along and introduce the topics. So while it may have seen early on in the first couple lessons and parts of the course and learning path that we were doing really bad things, it was intentional. That way things are simpler for people, right? If you've ever done like Spring stuff with injection, right? Like if you just start out with that and that's your very first experience to like programming in Java and using a framework, your head's going to spin because you're like, well, I don't know where this stuff's coming from. It's just magically being injected in, right? So you got to sort of start and see the easy way first, straightforward way. So a lot of stuff was hard coded, and so we're going to remove that hard coding and then inject stuff in on the fly. Okay. So basically what we're saying here, hey, we're going to go and we're going to look at that Docker file that was used to create the web server. Okay. We got some warnings here. I need to fix these. Nothing's ever perfect all the time, is it? Darn Kubernetes always changing on us. All right. So here we are. Okay. All right, I'm in here. Let's go and look at that Docker file. So in this scenario, what was done was we started with an Ubuntu image. We copied two things into that image. We set a working directory and said, hey, when the image starts, the container starts, I want you to execute the binary at /opt/go/web app. Okay. Now, here's the problem. If we go back to here, and if we look inside here, sorry, here we go. Let's go inside the config directory, and let's look at what here. Well, there's a single file, and it's a JSON file. And if we look inside here, it's basically a configuration for the application. And notice it's got things like a username, a password, a host name, and a bunch of stuff that like really shouldn't be in there, right? We'd want that to be injected in. Hopefully it's different for each environment that you're on and so on and so forth. So what we're going to do is we're going to change this, right? And so if we go back to here, all right. So our first to-do says we're going to add an environment variable definition for default of DB password. Okay, and so basically the explanation here, it's sort of a little bit implied. We should do a better job at this, but the application, if an environment variable of DB password shows up, it will use that and it will override anything that was in the configuration file. Okay, so what we're going to do is we're going to do that up here. And I happen to know this, but if you follow this URL in the comment here, it will show you the syntax for it, right? So if we take this, copy it, Let's go look at that. env, not much surprise here. It's the name of the environment variable and then the text of it, right? So we're going to do one called db password and my default password. All right. Cool. There we are. All right. We've already done the copying of the code. We've already done, we're now going to remove the configuration line. So that JSON file is not going to be inside the Docker image or the container image anymore. So the Go web app won't work unless we supply it at runtime. And we're removing it from being inside the image. All right. We're also going to do a volume definition here. Okay. Because what we're going to do before we put that in, when we did it before, we put something at that location. Okay. So we're going to do volume. We're going to do like this. Okay. Let's copy that. Here. Back here. Put the volume definition in here. All right. And we're going to do a volume of /ops/ go web app /config. Okay. All right. Let's get out of here. All right. Now we're going to do a build and we're going to make it a different version. Okay, cool. If we look at our images, we see that the V2 is 3 seconds old and the other one is 5 minutes old. Okay, cool. So, and if you have any questions about what I'm doing, please let me know as we go. All right. So right, this V2 does not have that inside of it. Actually, if we try to run it right here, Docker run web app :v2. Make sure I'm okay. See, it threw an error and crashed, right? But watch if I do that with V1. It started up. It couldn't talk to the database because I didn't set anything else up, but notice the difference. So we can confirm, yeah, the configuration file's not in there. Okay, great. Should probably remove some shit here, huh? Oh, there we go. Okay. All right. So we're going to push this version into the registry. And we are going to then use it in our in the updated Kubernetes definition. So if it doesn't have the configuration file in there, we got to figure a way to get it in there, right? We got two things. So one, we're going to use two injections. We're going to inject in the password as an environment variable of that db_password. And then we're also going to inject in that entire configuration file on the fly, that config.json I showed you, and put it in there. So we're going to, and there's two different mechanisms we're going to use for that. The first one for the password, Kubernetes has a built-in mechanism for providing confidential or secret information, and the object's called a secret, right? And so we're setting it to my password, and if we describe it, it's in there. It's basically just putting in the data. Quick disclaimer, I will tell you, most of you who operate Kubernetes clusters in a production sense probably won't use the built-in Kubernetes secrets. You probably have some other type of secret management tool that you use, like HashiCorp Vault or something else similar. And most of those secret or credential providers have plugins to make them work in Kubernetes. Or if you have your own homegrown one and it's already been signed off by your auditors, if you have to go through security audits, that's cool too. All right. So what we're going to have to do, that's great. We also need to make the database do it too. Now, the good news is the MySQL database already has this set up. We just need to, we don't have to modify that Docker image. But what we do need to do is modify the YAML. All right. So if we go down to the password section here, it's hard-coded, my password. Okay. And so what we're asking to do here, we're being asked to do in the lab, is we're, instead of having it being hard-coded with a value right in there, we are going to add in value from, and then we're gonna, so instead of the value being a literal in that YAML file, we're gonna reference it from somewhere else, and we're gonna use a secret key ref is the thing here. And we're gonna say the name is MySQL and the key is password. All right. Now you might ask yourself, well, where did these come from? And I'll show you in a second once I get out of my editor. There is a workaround we have to do right here on this line down here with the where we put in the command. You can see some details of this. We have a health check in there, and the password, basically, we're going to have to inject it in this way down here. I think I got that in there correct. Yes. There we go. Okay, we should be good. All right. So when we ran that secret command to create the secret, I'll just show it up here in the instructions. kubectl create secret MySQL, and then we called, I know it can be confusing here, the two equal signs. Basically, imagine that this is what matters. The dash, this first equal sign is for the actual command, and then the last pair is the actual combo. So password is the key, my password is the value, and hence why down here in the YAML file we set the key to password, the name to MySQL, right? So the key was password, and the MySQL came from this right there, the name of the secret, and then the name of the key. That's where that comes from. All right. So we updated it. We need to make sure our image is looking good. Let's see if we have that in there. I can't remember. I think it's already been replaced, but let's look. Yes, it has. So we should be good. And let's apply it. And let's see where it's goofed up. Oh, we didn't. Okay, it configured it. Updated. Great. Let's get pods. Database is recreating. 0 seconds old. All right. So that will dynamically supply that. If we do kubectl describe, and I know I'm running low on time here. We'll try to get through as much as we can. Oop. We will notice up here MySQL password, and it's set dynamically on the inbound. Okay, so we got that. Is it there yet? Is it running? Almost. Okay, we're going to make another secret for the Go web app. Sorry, we're going to do a config map this time. A config map is a collection of key value pairs. In this scenario, the key is being called web app config. Sorry for this. Web app config JSON. And the value is the contents of the config.json file. So basically, we're taking all of the lines of that JSON file and we're putting it into a string and then assigning that to an environment variable. You can think of it as, right, of web app JSON config. And that's what we're doing here. Okay. And if we dump the config or the config map, we see that this is all the stuff inside of it. So a lot of times when we think about environment variables injected into something, we think of something like a one-line thing, like a little code, the name of something, a URL, etc. This one just happens to be a longer string of text, which is the configuration file. All right. So now we're going to go and we are going to update the Go web app, its YAML file, to no longer have the hard-coded configuration. All right. So we're going to come down here. We have the same scenario, right? So the password was hard-coded just like a value. What we're going to do here is going to be the same value from. I see we have a question too. Secret key ref. So we're using the same secret, but we're injecting it into two different deployments, one for the front end and one for the back end. This needs to say this. Okay. And we're going to change this one to use v2. Okay. And then we're going to come down and use this volume mount stuff. Real quick, there's a question. What's the advantage of the JSON injection? The advantage of that is that if we didn't do that, right, we'd have to build, let's say that we had 3 environments. We had production, we had QA, and we had a dev or test environment. I'd have to build 3 different Docker, or 3 different images every time, where each of those would have a different config.json file inside of the image that had the values that were relevant for that particular environment, which is not ideal. Additionally, from a security perspective, that if somebody can get at that container image, they then also have those values because they're actually stored on disk inside there. And so that's a negative thing as well. And so that's why we're doing the injection on that side. Hope that helps. All right. So we are going to add in a volume mounts that is at the same level of the readiness probe. Okay. So what we're going to do, you can watch me type this stuff. Even though it's just a string, Kubernetes has a mechanism to fake it out as a file. Basically, behind the scenes, it's going to make a temporary file system. It's going to dump the config map values into as files in that file system and then mount it into the container. The application, our Go web app, doesn't know that all this is happening. All it knows is when it runs and it looks for config/config.json, it finds it. He doesn't really know that it was just made a few seconds ago. It was mounted in from outside the container. The kubelet went and made that on the fly, and it came out of the Kubernetes API from a config map object that we put in there. It can swap out. Doesn't know any of that. All it knows is there's a file there. All right, so that's what we're doing here. The name, config volume, which is going to match from down below, and the mount path is where it should be, which is basically the same location that we deleted, that line we deleted from the Docker image, the Docker file. Okay. All right, now we're going to make a volumes, which is out here at the higher level. And we are going to set the name to config volume. It matches what's up on two, 3 lines above. And then we are going to use a config map as the source, as opposed to a PVC or something else like that. And if you recall this line, I just typed web app-config.json. That was the when we made the config map via the command line, that was the three things, two equal signs part. It came from there. All right. Cool. See if I typed this correctly. Question: is there any protection here for the SQL injection type hack or risk? There is not, because this is not part of that. This is configuration going into the config, the properties file that starts the application up. The SQL injection kind of stuff would happen in the action, that would be dependent upon the actual source code of the web server application to make sure that it was doing all the appropriate best practices, going through frameworks and escaping and all the other things to make sure that doesn't happen. All right. And we're almost at the top of the hour. Let's see if it's, did I goof it up? Yes. What did I miss? Missing a required field of name. All right, where'd I miss a name? Probably at the bottom. Items. Set the config map name to Go Web App, which I did. Name to config there. I have those there, name. Ah, look at that. That's probably it right there. That's better. All right. Let's restart. We are restarting and I have an error. It's crashing. Let's see what I messed up on. Didn't mess up on anything. Psych, right? It's because the database is still not ready. I might have messed up on something from that before. We could check that out. But if we do a kubectl describe on the Go web app, the one that's crashing, let's do that. Okay, cool. If we go into here and we look, we see the ops Go web app config is coming in from the config volume. Awesome. All right, that's great. It's probably crashing because it can't get to the database. Let's confirm that. Connection refused from the database, but as mentioned above, that is because our database is having a problem. Let's go look at the logs of the database. All right, it started up okay. That's good. But what are we missing in it? The wrong password, maybe? Did I not put the password in correctly? There's probably a password mismatch in when I set up that probe. For the sake of being at the top of the hour and being respectful of people's time, let's do this. Let's get rid of the probe so that I don't continue to waste time on that. All right. I might have to delete it because it looks 10 minutes old. kubectl delete pod web app minus QL 0. All right, let's see if we recover. So for the sake of the top of the hour and the live demo gods, etc., we're going to see if we get, so it's running, that's good. And hopefully on this 5th restart, the new Go web app will succeed. If it doesn't, I apologize that it didn't end successfully, but I hope that you still learned some things. I'm going to go over here to questions and see if we have any more while this continues to go. This is, maybe. Maybe. Hey, all right, we did it. Whew. Just in the nick of time, almost the top of the hour. I was worried there. I didn't want to screw up too bad. Technically, I did remove the thing, but the probe, but I can put that in, diagnose it afterwards. I will potentially go look at that. So thank you all. Thanks for the questions as well. This is part 4 of the learning path in Kubernetes. We got through the storage and the dynamic application configuration. And the last one, we talk about jobs and security. We do have one more office hour happening next month. We'll hit you up on the same email chains, and they will be posted on YouTube if you want to share it with somebody. And then we'll have a whole collection, the whole collection of these we're going to add in to this learning path at the end as supplemental information as well. Because sometimes it is nice to, I guess, see me mess up and make mistakes, right? We all do it. So I thank you all. Everybody have a wonderful week. Thank you for attending. And I will just stop the recording and hang out here for a few minutes if people have questions on chat. Take care.